Hi, everyone. Thank you so much for joining us. My name is Donna Arthur, and I work for the admissions department at Missouri S&T. And tonight we're going to talk about geological engineering. So joining us is Dr. Jeremy Maurer with the Geological Engineering degree department. And I'll let him go ahead and start his presentation.
Thanks, Donna, and thank you all for watching. So I'm going to talk about geological engineering, which is just one of 3 degrees that we have here at Missouri S&T in the Earth Sciences and Engineering department. We have geological engineering, geology and geophysics, and petroleum engineering. And geological engineering, there's going to be a lot of similarities and overlaps with the other 2 degrees, but I'll talk about some of the differences as we go along. Let me make sure my PowerPoint is working. And minimize that. So geological engineers are sort of working at the intersection of earth science and engineering, and they solve important problems related to natural hazards, environmental protection, resources. But geological engineering is actually one of the broader fields of study that you can do at an undergraduate level. So there are graduates from our program that are geological engineers that work in civil engineering or for civil engineering firms. There are graduates that work for mining engineering firms. There are graduates that work for remote sensing firms, earth observation firms, government, U.S. Geological Survey, Missouri Geological Survey. So it's really a kind of lays a broad foundation for your future career, whatever that might look like. Geological engineers can work inside or outside, lots of different types of work, as you can imagine. Having such a broad background allows you to work in many different kind of contexts. And, well, you won't be bored. It's lots of exciting work to do. So what kinds of specifics do geological engineers do? So one area is natural hazard mitigation. A big area for engineering is slope stability and dealing with landslides and liquefaction, stability of foundations, things like that. And this is really a major area for geological engineers. Many of our graduates work for geotechnical consulting firms or geotechnical engineering firms, and they're looking at everything that is built on the ground or through the ground or in the ground. And so they're looking at, can the ground support those buildings or those structures or tunnels or bridges or any number of things that are engineered structures. And of course, trying to avoid and mitigate the natural hazards that can come from different things like landslides or sinkholes or liquefaction. So that's one area. Geotechnical engineering specifically is kind of a sub-discipline within geological engineering, which is focused on, again, structures, building conditions, foundations in particular, focusing on different types of foundations for different types of structures. And that could be buildings, could be dams, could be bridges, could be any number of types of structures, but looking at is the ground that structure is built on going to be able to support the weight, support the stresses that are imposed by that structure. Environmental aspects of geological engineering are really important as well. And so one area is, for example, in groundwater remediation, but really any type of environmental work, environmental consulting. This is a really important field for geological engineers. And we have graduates working for various environmental firms, environmental consulting firms, doing cleanup work, things like that. Also, the USGS and Missouri Geological Survey are sometimes involved in these kinds of projects, and we have graduates working with them as well. Groundwater supply, so making sure that people have fresh water to drink. This is actually an area which overlaps quite a bit with geology and geophysics, looking at aquifers, looking at using geophysics to detect aquifers and how large they are, how much water they might be holding, using geophysical tools like electrical resistivity tomography and EM systems, electromagnetic systems, can allow us to do things like look at contrast between different types of geological materials. So an example would be near the coastlines of the country, there is sometimes saltwater intrusion into groundwater aquifers if there's too much pumping that happens in those aquifers. And so we can actually use geophysical tools to detect that and to try to mitigate saltwater getting into groundwater aquifers. Remote sensing is another big area. That's actually my specialty, and I do a lot with looking at earthquakes and earthquake processes. We try to measure ground deformation that leads to earthquakes, and also try to look at deformation which happens during earthquakes. That's just my area of research, but there's actually quite a few other areas as well that geological engineers can do. I've got a student working at who's graduated and is now working for a remote sensing firm doing monitoring of oil and gas fields and mining areas. Remote sensing can be done from satellites, can be done from drones, can even be done on the ground using GPS. So surveying is sort of a sub-discipline of remote sensing. And all of these things, all these tools and techniques are used to map and mapping everything. A lot of things need to be mapped, such as agriculture. So in Missouri, we do a lot of agriculture, and one of the areas that I've started getting into more recently and have some other faculty here in the department that are involved in is using drones to map agricultural fields and look for areas where plants might be more or less healthy. And so you may need to apply more or less fertilizer, for example, or pesticides or whatever. You can actually map plant health using drones. And you can also do the same kind of thing, although at lower resolution, from space. So the space satellites like Landsat and Sentinel-2 are able to see plants and plant health in a similar way to drones can, but at a much lower resolution, of course, because the satellites are further away. Other satellites might look at thermal images, or drones as well, might look for thermal anomalies, like what happens around volcanoes or geothermal fields. And other ones might look at other types of measurements, not necessarily optical measurements, but maybe using radar. And that's some of the deformation measurements like what I work with. Another big area so I mentioned deformation, and one area of deformation that some of my colleagues here at the university have studied is actually related to ground subsidence caused by groundwater pumping. So for example, in California, there's been large-scale subsidence of the ground of meters, actually multiple meters, because of groundwater pumping. And that happens in other areas as well, in other areas around the country, including Colorado, like what you're seeing here on the screen, where over a number of years, the ground level has actually dropped more than 2 feet. Geological engineers also look at surface water, so not just groundwater, but also surface water, and in particular, look at structures that are controlling surface water, like levees and dams. In fact, several of the students that I've worked with are specifically looking at levees and dams to either, one, characterize the geology that they're sitting on, characterize the foundations of those levees and dams, or try to detect and measure possible deformation of the dams. So many dams in the United States are getting older. Some of them are, sometimes from time to time, there'll be a dam failure. And of course, we want to avoid that if possible. And so sometimes we can look for precursory deformation of dams and identify, oh, this particular one needs to have more work done to identify if this needs to be replaced. And so we can use some of these tools that I mentioned, like remote sensing and drones and other geotechnical information to identify whether dams or levees need to be repaired or replaced. Renewable energy is obviously a really big area of growth these days, and geothermal power and solar power and wind power all involve geological engineering to some degree. For example, I have a student who took a class of mine, and that student was looking for old abandoned mine fields that couldn't really be used for other purposes, but they were building solar power plants on those abandoned mine fields. Those wind turbines need to have strong foundations, and so they're building on, looking at the foundations, making sure that building on those surfaces is not going to cause a problem. And of course, geothermal power is important. That allows us to get clean, renewable energy. And geological engineers can be involved in both the development and exploration for those power plants. Now, I've mentioned geophysics a bunch already, but that's kind of another specialty area. There's actually a number of companies doing geophysical consulting. And you see on the screen some different types of geophysical methods, electrical resistivity on the left and seismic on the right. And these are different methods that we can use to get information about the subsurface without having to actually dig up the ground. And so that's great. If we can get information, the information that we need about maybe the strength of the materials or what kinds of materials are down there, looking at groundwater and how it's moving in the subsurface. If we can do that without actually having to dig up the ground, then we can really get a lot of valuable information. And so geophysics is one way of doing that. And you have a lot of geophysics, obviously a lot of overlap with geology and geophysics as well, but a lot of geophysics here in the geological engineering program at Missouri S&T. Mining is another big example. In fact, at many universities, mining and geological engineering are actually the same department. Here, there are two different departments, but a lot of overlap again in the work that's done. And so many of our graduates have gone on to work in mining areas or for mining companies. And finally, quarries is another area where you want to extract maybe solid rock or maybe gravel or aggregates of various types, and geological engineers are involved in that process as well. So lots of different kinds of places where geological engineers work, lots of different career possibilities. I mentioned at the beginning, this is a very broad field. And when you take classes at S&T, you'll take classes in a range of these areas. And obviously, as I've already mentioned, they work in many different places. There's great job security. Geoscientists are in great demand, and the demand is growing thanks to things like critical minerals, which is an important area for national security as well as technology. There's increasing demand for critical minerals, and especially critical minerals that are developed here within the United States. So this is a growing field, going to be continuing to grow for quite a long time. Obviously, our traditional fields like geotechnical engineering, geological engineering, and mining, and oil and gas as well, those are going to continue to be important fields in the future as well. And a geological engineer can be professionally licensed as both an engineer, professional engineer, and a professional geologist. And so, again, you have that flexibility on where you're getting your jobs. Now, S&T's program in particular is a really great program. It's been ranked #1 in the nation by this particular website. It's a great program. We've got a small number of students, so the faculty are really able to give really one-on-one personal attention to all of our students. We do really a lot of hands-on work, field-based courses. Actually, I've been here now for about 4.5 years, and I've been really impressed by just the number of courses that are really hands-on, practically focused, getting into real-world problems that you're going to face in a job. So that's been really great to see. And we've got some great scholarships available for students, really great faculty, student groups, and all of that. So S&T is a great place to come if you are interested in geological engineering, and it's a great place to connect with other students in this area, and alumni as well. We have a lot of great alumni. So if you're interested, obviously you can, you've seen this video now, and hopefully you're excited to get more information and maybe apply. So you can see these websites here. You can also just do a Google search. Missouri S&T, Geological Engineering, Earth Sciences and Engineering is our main department page there. Any of those things are going to get you the information that you need. You can also email our program head, Dr. Catherine Grody. See her email there. And feel free to reach out to me. My email is jmaurer@mst.edu. That's JMAURER at mst.edu for more information. And I think that is all I have. So I'm going to stop sharing here. And thank you all very much for listening.